This is Himabindu from the Department of CSIT. So today in this video I would like to explain about the topic called Chomsky hierarchy of the languages. So here these are the slides. So what is meant by Chomsky hierarchy? So where we are using? So this Chomsky hierarchy from starting onwards we are discussing in the theory of competition. So there is a hierarchy of grammar. So what are the hierarchy? So how many types of grammars we have till now we discussed. So here till now we have discussed about the languages and grammars. So regular grammars, regular languages, and context free grammars, context free languages, and context sensitive grammar, context sensitive languages, and Turing machine. So here this Turing machine grammars, unrestricted grammar, and Turing machine, so unrestricted languages. So these are all discussed in the previous video. So how we are interrelating? So this all types of grammar, how we are interrelating in the diagrammatic representation, we will see. So here the Chomsky hierarchy represents the class of languages. So how many types of languages we have, we will represent all together in a one hierarchy that are accepted by the different mission. So here for every language, so different types of missions are there. For every language there is one type of mission. So we will discuss. So the category of language in the Chomsky hierarchy. So here what are the languages we have? Unrestricted grammar. So that is naming representation. Type 0, which is about the unrestricted grammar, or enumerated or language. Enumerated grammar, we can name it as a enumerated language or grammar. And next type 1, so which is a context sensitive grammar. So context sensitive grammar, we can write it as context sensitive grammar, and we already discussed in the previous videos the type 1 grammar. So which is mission which relates with this grammar is a linear bound automata. And type 2 is a context free grammar. So there is we can say that it is a restricted grammar. So what is the difference? We already saw in the previous video, like there is a restriction between production rules in the production rules. So the left hand side, how many terminals we need to represent, and the right hand side, how many terminals we need to represent. These are all the restrictions which are following in the context free grammar. And next type 3 is grammar, is a regular grammar. So here this regular grammar is totally restricted grammar, we can say that. And here, so these are all the types of grammars we need to discuss right now. And here what is the unrestricted grammar? So this unrestricted grammar in the hierarchy representation, how it is, we will see. So here this is the hierarchy representation. So here the type 0, so which is unrestricted grammar and recognized by the Turing machine. So we are recognized by this. So this unrestricted grammar which is recognized by the Turing machine. And type 1 grammar, which is a context sensitive grammar, which is recognized by the LB, linearly bound automata. In the previous video we discussed how this linearly bound automata, what is the tape symbol representation, we already discussed. And type 2 grammar, which is a context free grammar, so which is recognized by the push down automata. So here the push down automata is recognizing this language. So that is nothing but type 2 language. And type 3, which is a regular grammar, which is accepted by the finite automata. So this recognized by the Turing machine, and these are all accepted by this. These are all accepted by the automata. So the first one is about the machine, and the remaining all are automata. So remaining all are automata. So that is accepted by. So accepted by the automata. So this is the hierarchy and diagrammatic representation of all the languages in the theory of computation. So here this is the hierarchy. Therefore, every language of type 3 is also a type 2. So here this is a subset. So if you observe this, type 3 is a subset of type 2 and type 2 is a subset of type 1 and type 1 is a subset of type 0. So here with that we'll take this type 0. So we can say that this type 0 type 0 is we can form with the type 0 we can form all these remaining automata. So like that every language of type 3 is also a type 2 and type 2 is also a type 1 and type 1 is also a type 0. So there is a interrelation or hierarchy in between this all grammar, so that we can say that it is a Chomsky hierarchy for the given for the languages. So every language of type 2 is also a type 1 and type 0. So for every language there is a subset. So there is a subset of remaining languages, so that we can say that. So this is the hierarchy of the languages. And coming to the type 0 grammar. So type 0 grammar, which is the first one. So it is about the unrestricted grammar. So we'll name it as a unrestricted. Type 0 is known as a unrestricted grammar. So there is no restriction on the grammar rules of these types of languages. So by seeing the name only, we can say that this is an unrestricted grammar. So no restriction on the grammar rules. So we already discussed about the grammar. So in that one we have the production rules. So in that production rules there is a restriction. So left hand side and right hand side there is a production rule which is a combination of alpha beta. So here the alpha and beta, the length, so which is very important, the alpha beta, length of the language, length of the production rule, right hand side and left hand side. So these languages can be efficiently modeled by the Turing machine. So these are languages which are recognized by the Turing machines only. And these languages are also known as the recursive enumerable languages. One is type 0 grammar, which is first also known as unrestricted and recursive enumerable. So these two names for the type 0 language, type 0 grammar. So that is nothing but Turing machine. So here there is the two names are there for this type 0 grammar. So one is the unrestricted grammar and recursively enumerable languages. These languages are named as a recursive enumerable languages. And grammar productions in the form of alpha tends to beta. So production rules which is having the alpha and beta. So this alpha length and beta length we will discuss. The alpha is a combination of V plus T. So it is a combination of terminal and non-terminal symbols that to clean closure. So that empty string is also acceptable here. Empty terminal or non-terminal also. And V plus T star. So star represents, we already discussed what is the difference between the plus and star. So the star indicates it is also having the empty string. There is nothing but epsilon symbol is there in the language. And so on. And alpha, there is it is a combination of V plus T whole star, V plus T whole star. And V is nothing but variables and T is nothing but terminals, and B is V combination, V plus T whole star. In the type 0, there must be at least one variable on the left hand side of the production. So in the right hand side, so in the previous context sensitive, we discussed the length of the alpha less than or equal to beta. So this is about the linear bond automata. So, and coming to the type 0 grammar, that is a unrestricted grammar type. So, there is a alpha, which is alpha, it is a at least. So, at least one non-terminal. So, like that, a V, or it is a combination of V plus T whole star. So that's why the V is there. If you substitute this V plus T whole star with the epsilon and this epsilon, so epsilon into V, so here the V is the must and should there. So at least one variable on the right hand side of the production. So alpha, which is having the at least one variable on the left hand side, and the terminals, and beta, which is a combination of V plus T, or only single V or single T, or whatever is accepted here. But in the left hand side, at least one variable should be there. So for this conditions, what is the example here? SAB. So there is a no length restriction. So here in the LBA, we have the restriction like length of alpha is less than or equal to beta. But in the Turing machine, we don't have that kind of length restriction. So that's why we named as an unrestricted grammar. And SAB, so here there is a three left hand side, there is a 3, length of the left hand side is a 3, and here the length is a 2, and here 1 2 1 1. So that with this grammar we can say that it is a Turing machine or recursively enumerable language. So that this left hand side, we at least one non-terminal or terminal should be there. Only terminal, non-variable should be there. So this is about the type 0 grammar. And type 1 grammar. So type 1 grammar generate the context sensitive languages. So we already discussed. So the language generated by the grammar is recognized by the linear bound automata. So this grammar should be recognized by the linear bound automata. The context sensitive grammar follows this rule. So what are the rules we need to follow for the context sensitive grammar? The context sensitive grammar may have more than one symbol on the may have. So there is a may have more than one. So in the previous type 0 grammar, at least one variable should be there. But here, more than one left hand side of the production rule, more than one symbol. So what they are not asking about only single or length of the alpha should be one or at least one. So there is a combination of there is a possibility of left hand side more than one symbol, and the number of symbols on the left hand side must not exceed this is the condition alpha, which is less than or equal to the beta. So this is the condition which is followed by the linear bound automata. And the rule of the form alpha A tends to epsilon. So A tends to epsilon is not allowed unless A is the start symbol. So here, if it is A is the start symbol, then only the epsilon is considered. So in between this, the V is equal to S comma A comma B is there. In this one, if A is the starting symbol, then only A tends to epsilon is included. Other than that, this if S is the starting symbol, this A tends to epsilon is not should be there. And this is the condition we need to follow. So that is the rule of the form A tends to epsilon is not allowed unless A is the starting symbol. It does not occur on the right hand side of the any row. So that's why, so in the right hand side, A tends to epsilon should not be there. Why? Because this is a type 1 grammar. So there is a conditions. And the type 1 grammar should be type 0. Then in type 1, production is in the form of V tends to T. So in the production rules of type 0 also, we have the production V tends to T. So that is nothing but capital A tends to small a. And like that, here in the type 1 also, there is a possibility greater than or less than or equal to, so that v tends to a is also possible, that is nothing but a tends to a. So here these two types of grammar should be same in this situation, that is a terminal symbol situation. That's why the type 1 grammar should be type 0, and in type 1 production is in the form of v tends to t. So where the count of symbols in V is less than or equal to T. So this is the V less than or equal to T. And type 1 grammar, which is a condition, the alpha. So length of the alpha is less than or equal to beta. So in the production rule, so that left hand side we have, suppose here, if you observe this example, so left hand side, 1 is there, length of the alpha is equal to 1, and here the length of the beta is equal to 2. So that 1 tends to be 2. So that length is equal to, so greater, less than or equal to 2. So this production rule is satisfying this type 1 grammar. And this is the count of the symbols, alpha is less than or equal to beta. And beta, so which is belongs to the v plus t. And here this beta, which is not included this epsilon symbol. So beta tends to epsilon is not, it should not be there in the grammar. And that why we named as a v plus t plus. And beta cannot be epsilon. So the what we discussed. So why? Because this plus represents, so if we represent it as a v plus t star, so we can say, we can include the epsilon. And here this beta, which is we are writing it as a plus symbol, so epsilon is not included. So epsilon is not included in the plus. So that, so b cannot be epsilon. And here if you observe this grammar, we this production rules, so AB, length of the alpha, which is length of the alpha which is less than or equal to beta. So beta, which is not having the epsilon symbol, and also length is 3 here, the length is 2 here. So that we have satisfying 2 less than or equal to 3. And here 1 less than or equal to 1. So that equal representation, 1 is equal to 1. So that we can represent. So this is the V tends to T. So that with the only the type 0 is having only this condition is also having. So in this one type 1 also it is having. So that we can say, we can represent, but we can represent both type 1 and type 0 as a same. So this is about the type 1 grammar. And type 2 grammar, so which is generated by the context free languages. So this we already discussed in the previous videos. So the context free languages which are recognized by the push down automata. So this push down automata, which is having the tuple representation and stack representation. If we briefly discussed about the push down automata, we have the stack representation, and we also have the finite control FC, so that we can accept and reject. So we can accept and reject with the control. Finite automata, sorry, not finite control, it is so here like this we are moving the elements into the stack, and we are popping the stack, and based on that we will accept or reject that language. And here this type 2 grammar or type 2 grammar we are named as a context free grammar. The first of all, it should be a type 1. Maybe the left hand side of the production can have only one variable, and there is no restriction on beta. So here left hand side only one. So what we are discussed, so left hand side the only v should be there. No, other than that nothing. So there is a not a combination v plus t whole star, or v plus t plus is not plus is not possible in the type 0. So these are all not two possible. Only single, that is nothing but length of the alpha, which is the V. So like the A tends to A, like that only. This only left hand side, only one terminal should be one non-terminal, only non-terminal, not a terminal, only non-terminal should be there. That is nothing but only one variable should be there in the left hand side. And the right hand side, there is a no restriction. So there is a combination of more number of more number of terminals and non-terminals. So here this is included for the beta. So here, by observing this example, so left hand side we already only having the 1, length of the alpha is equal to 1, and beta, so there is a combination of only terminal and a combination of terminal with the non-terminal. So there is no condition on the beta, no restriction on the beta. Only the left hand side, it is having the only single variable or single non-terminal. So that is the condition we are following for the type 2 grammar. And type 3 grammar, so is known as a regular grammar. Initially, in earlier classes, we discussed about the regular grammar only. So finite automata, DFA and NFA, these are all related to the regular grammar. So the regular grammar languages are those languages which can be described using the regular expressions. So how we are going to describe in the sense this regular expressions. So these languages can be modeled by the NFA or DFA, non-deterministic finite automata or deterministic finite automata. This type 3, which is most restricted form of the grammar. So we can say that type 3 is the most restricted. So why? Because we will discuss. The type 3 grammar should be a type 2 and type 1. Type 3 should be given in the form of, so V tends to VT at terminal. A left regular grammar and right regular grammar. So here for this one, how we will write in the sense, V tends to, suppose we will take one grammar and we will write the grammar which is having A comma B as a variables and terminals A comma B small letters and the production rules. So P is the production rules we will write, and S is the A is the starting symbol. So A tends to VT. So VT in the sense V is a variable. So B we will write again B, and T is nothing but I will write A. And here is one type of grammar. So that is a left regular grammar. So how we can say that it is a left regular grammar in the sense, left hand side of the production rules in the beta side. So beta side. So in this beta side, we have the terminals. So non-terminals which are in the left hand side, we can say that L regular left linear grammar. And beta A tends to right hand side. If you observe right hand side, the variable which is in the right hand side, we can say that left linear grammar. So these are the two types of regular grammars we have in the type 3 grammar. And for example, S tends to A. So S tends to A is the strictly regular grammar called as strictly. S tends to A. So S is nothing but a variable or non-terminal which is representing the terminal symbols, only single terminal symbol. So this is called as strictly regular grammar. So there is another form of regular grammar called extended regular grammar. So what is this extended regular grammar? So V tends to V T star. So T star represent the extended left grammar, and T star V and T star represent, suppose here the terminals so which are having the A comma B. So V tends to, so that is V tends to A, capital A, B is there. We will take one left. So A tends to VT. So A will take and T star represents. So first we will include epsilon, this epsilon or and if you take A star means A. So this is nothing but A power 2. So this T star will take it as a A2 only. And again we will write it as a triple A and A triple A. So this T star represents the sequence of these terminal symbols, and also there is A tends to double A or A tends to maybe a chance of extended regular grammar while using the grammar which is having extended left regular grammar. We can represent it as A tends to triple A or based on the length. And like this here, this is the left. So, and we will write A tends to right linear grammar. So, triple A. And here we'll make it as a B. And also A tends to. So, we will write a B, BB like that. So, here based on the language. So based on the languages, we have to divide the protection rules. So these are all about the extended regular grammar. So this is about the left linear grammar and right linear grammar in the regular grammar. So this is about the type 3 and this is about the example. So it is a combination of S tends to AB. So terminal. So not only single terminal, we can also have the multiple terminals. So multiple combination of terminals. So this is about the regular grammar type 3 grammar. And let me summarize all the grammars. So first one is about the type of 0. So which is unrestricted grammar, unrestricted grammar. So unrestricted grammar which is recognized by the Turing machine. So Turing machine. And type 0, type 1, so is it, what is the type 1 grammar in the sense? It is a context sensitive. Context sensitive. So context sensitive grammar and which is recognized by the linearly bound automata. And coming to the type 2, so it is a context free grammar. So context free grammar. So which is recognized by the language, recognized by the machine called push down automata. Push down automata. And type 0, type 3, which is a regular grammar, regular. So regular grammar which is recognized by the finite automata. So that is nothing but NFA, DFA, NFA. So these are all about the Chomsky hierarchy. It is having the 4 types of grammars. One is a unrestricted grammar and a context sensitive and context free and regular grammar. So this is all about the Chomsky hierarchy. And these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.